Hello, I welcome you all to your own channel MSK Learning. In this video, we will solve one numerical problem which is related to the four noded element, or we can say the problem based on the quadrilateral shape, right? So one problem on the screen, a four noded quadrilateral, the xy coordinate of each node are given in the figure. The element displacement vector is given as that q is equal to, this is the nodal displacement, you can say q is equal to that 0, 0, 0.20, 0, 0.15, 0.15, 0, 0.05. As I said, it is a problem for quadrilateral, so means the four node is there and each node is having 2 degree of freedom, means the total displacement will be 8. So you can find 1, 2, 3, 4, 5, 6, 7, 8. So these are the 8 nodal displacement for 4 nodes, means each node is having 2 degree of freedom, means the 2 nodal displacement. Now we need to find out this is the figure is given for the quadrilateral. This is the node 1, node 2, node 3 and node 4, right? These are the coordinate is given for each node, that is you can say this is x1, y1, x2, y2, x3, y3, x4, y4. We have to find first one, the xy coordinate of a point P whose master location element epsilon is equal to 0.5 and eta is equal to 0.5. Second one, we have to find out the uv displacement of the point P. Let us say anywhere the point P is located in this quadrilateral shape. Let's say this point is P. So here we have to find out the xy coordinate, right? As well as we have to find out the nodal displacement, that is uv displacement we have to find. First of all, we will find the shape function at each node, means n1, n2, n3 and n4. So this is the quadrilateral shape. So for that we have to see that 1 by 4, 1 minus psi, 1 minus neta, as you know. So here we have a solution, right? So first of all, the given is that the nodal displacement is given, q is equal to 0, 0, 0.20, again 0, 0.15, 0.10, 0 and 0.05 in transpose, right? So these are the nodal displacement is given, means you can say u1, v1, u2, v2, u3, v3, u4, v4. 4 nodes, 4 nodal displacement, and each nodal displacement at each node we have a 2 degree of freedom, means 2 node displacement at each node, means 8 nodal displacement, right? Then the master location is given, that is master location of shape function, master location of element, that is psi is equal to 0.5 and neta is equal to 0.5, right? So in 4 noded element, first of all we have to find out the shape function, right? So if we see this is, let's say this is the 4 noded element, that is quadrilateral element, right? So this is the node 1, just for understanding. This is the node 2, node 3 and node 4, right? So now this quadrilateral body is kept in a plane, that is assume this is our xy plane, is it or not? This is the x and this is the y. So it means that if you see, then this node 3 is in the first quadrant, node 4 is in the second quadrant, node 3 in the third quadrant and node 4 in the fourth quadrant, right? So it means that these master location we can denote by psi and neta. So here the psi value will be, that is, this is what in third quadrant, means x and y both will negative, so it is minus psi and minus neta, right? In second quadrant, that x is positive and y is negative, so x is represented by psi, so this is plus psi and this is minus neta, right? First, this third node is in the first quadrant, both will be positive, that is plus psi and plus neta. In fourth node, that is it is lying in the second quadrant, so in second quadrant x is negative, means minus psi, and y is positive, that is plus neta, right? So these are the values we got. Apart from this, we have a coordinate is given in the figure, right? So these are the coordinate is given, node 1, node 2, node 3 and node 4. So let us say this is the node 1, node 2, node 3 and node 4. So the coordinate is given x1, y1, x2, y2, x3, y3, x4, y4. Also we can find the x1 comma y1, right? x1 comma y1 is equal to what? That is given 1 comma 1. x2 y2 is equal to 5 comma 1. x3 y3 is equal to 6 comma 6, and x4 comma y4 is equal to 1 comma 4, right? So these are the coordinate are given. Now we need to find out the shape function by using this. So the shape function at each node, the shape function is 1 by 4, 1 by 4, right? So we can find, first we will go like this, that is, yes. So first of all we will find the shape function, that is n1 is equal to 1 by 4, 1 minus psi into 1 minus neta. How this psi and neta is came, that we have discussed that. Imagine that we have a 4-noded quadrilateral shape. This is 1, 2, 3, 4. So node 1 is in the third quadrant, x and y both is negative, so psi and neta will be negative. Second quadrant means if x is positive, y is negative. Third both is positive. Fourth, one is x is positive and y is negative. So as the third quadrant both is negative, so 1 minus psi, 1 minus neta. Then n2 is equal to what? 1 by 4. That it is in the the second quadrant. So second quadrant means x is positive, 1 plus psi, and y is negative means 1 minus neta, right? Then we have to find out the n3. These are the formulas, that is 1 by 4, right? Into this will be third is second quadrant, first quadrant means both is positive, so 1 plus psi and 1 plus neta, right? n4 is equal to means second quadrant, x is negative, 1 by 4, 1 minus psi, and y is positive means 1 plus neta. Psi and neta value you know already, which is given in the question. So 1 by 4, 1 minus 0.5, right, into 1 minus 0.5, right? And this is what you have, a 1 by 4 into 1 plus psi means 1 plus 0.5 into 1 minus 0.5, right? This is third, that is 1 by 4, psi is 0.5, 1 plus 0.5 and 1 plus 0.5, right? Then this is 1 by 4 and this is 1 minus 0.5 and this is the 1 plus 0.5. So these values we have substituted into the equation. Now we can get the n1, n2 and n3, n4. So you can simply simplify this equation and get the values of n1. So n1 is equal to, on simplification, we'll get the n1 values as, so when you simplify, that n1 value is 0.0625, alright. Then we have a n2 is equal to 0.1875, n3 is equal to 0.5625 and n4 is equal to 0.1875. It means that at each node we got the shape function. That element is like this, which is given in your questions, right? So according to this question, this is the body is given, the figure is given. So this is what you have, a node 1, node 2, node 3 and node 4, right? So here we got the n1, n2, n3 and n4, right? As we have discussed that y psi is negative and at node 1 and neta is negative at node, this we have discussed. This is lie in the second or fourth quadrant. It is in this is in third quadrant, this is in fourth quadrant, first quadrant and second quadrant, right? So on behalf of that you can say which psi is negative and which one is positive. Now we need to find out the first question we have, the xy coordinate of a point P, right, whose master location is psi is equal to 0.5 and psi is equal to neta is equal to 0.5. So first of all, first bit we have to find that xy coordinate of a point P whose master location psi is equal to 0.5 and neta is equal to 0.5. So you know the xy coordinate, x is equal to what? X is equal to n1 x1 plus n2 x2 plus n3 x3 plus n4 x4. We know n1, n2, n3, n4 just now we have calculated. x1, y1, x2, y2, x3, y3 and x4, y4 is given in the problem itself, right? So this is the figure which is shown in the question, that these are the coordinate is given. This is x1, x2, x3, x4, right? So now we have a x1 is what? We will substitute these values and we'll get the x coordinate, that x is equal to n1 we have a 0.0625 into x1 is 1 plus n2 is equal to 0.1875 into x2 is 5 plus n3 is equal to 0.5625 into x3 is given 6, right, plus continuation, that is 0.1875 into x4 is your 1, right? x4 is 1. So when we simplify this, that is 0.0625 into 1 plus 0.1875 into 5, 0.5625 into 6 plus 0.1875 into 1, n1, n2, n3, n4, x1, x2, x3, x4, right? So when we simplify, we'll get the x value is equal to 4.5625, right? Similarly, we'll go for the y coordinate, that y is equal to n1 y1 plus n2 y2 plus n3 y3 plus n4 y4. Alright, so n1 is equal to what? 0.0625 into y1 is equal to 1 plus 0.1875 into y2 is equal to 1 plus 0.5625 into y3 is equal to 6 plus 0.1875 into y4 is equal to 4, right? So this is what, that is n1 y1, n2 y2, n3 y3, n4 y4. 0.0625 into 1, 0.1875 into 1 plus 0.5625 into 6 plus 0.1875 into 4. So y value we got, which is y is equal to 4.375. Okay, so this is what you got, the x value here, and this is the y value. So our answer is that the xy coordinate of a point P, the xy coordinate of a point P is equal to 4.5625 comma 4.375. This is the first answer. Now we'll find out the second one, that UV displacement of point P, right? So for UV displacement of point P, what we will do, the same method we have to use. That next we have to find out the UV displacement of point P. Okay, so second one we have to find, second one is the UV displacement of point P, right? So UV displacement of point P means the displacement, nodal displacement is given in the question, that Q is equal to these values, right? So it means that this is U1, V1, U2, V2, U3, V3, U4, V4, right? So first of all, that is given U is equal to what? N1 U1 plus N2 U2 plus N3 U3 plus N4 U4. These are the formulas. And V is equal to N1 V1 plus N2 V2 plus N3 V3 plus N4 V4, right? From the question you can say U1 is equal to 0, U1, U2, U3, right? First we'll collect the data, and U4. Then also V1, V2, V3, V4 is given. From where? From the question. That is, this is what you have, that you can say, if you look at this is your u1, v1, u2, v2, u3, v3, u4 and v4. Is it or not? This is how we are writing the nodal displacement. Since one dimensional bar element problem we know, right? These are the alternate u1, v1. This is for nodal displacement for node 1, nodal displacement for node 2, nodal displacement for node 3 and nodal displacement for node 4. As it is the two-dimensional problem, right? So at each node we have a degree of freedom is 2. So this is u1, v1, u2, v2, so on. So now we can write that u1 is equal to 0 and u2 is equal to 0.20, u3 is equal to 0.15 and u4 is equal to 0. Similarly, v1 is equal to, we have a 0 and v2 is also 0, v3 is equal to 0.10 and v4 is equal to 0.05. The things is very easy. Now then you have to find out the u, that is nodal displacement. N1 is what? That N1 is 0.0. So it's very easy that if you will write like this. So N1 is equal to 0.0625 into U1. U1 is what? 0 plus N2 is 0.1875 into U2 is 0.20. This is 0.20, right? Plus N3 is 0.5625 into U3 is 0.15, right? Plus N4 is 0.1875. So this is continuation plus 0.1875 into U4 is 0, right? So U1, N1 U1, N2 U2, N3 U3 plus N4 U4. N1 is 0.0625, U1 is 0, N2 is 0.1875, U2 is 0.20, N3 is 0.5625, U3 is 0.15, N4 is 0.1875 and U4 is 0. So when we simplify, we'll get the U is equal to 0.1218, right? Similarly, we will go for the V, that is N1 V1. So N1 is what? 0.0625 into N1 V1 is 0, right? Plus N2 is 0.1875 into V2 is also 0, right? Plus N3 is 0.5625 and V3 is equal to 0.10 plus continuation N4 is equal to 0.1875 into V4 is 0.05, right? So this is what we got the V, that V is equal to 0.0656. Okay, so now we can write that UV displacement of point P, that is P is equal to 0.1218 and 0.0656. This is your answer. This is how we will solve the problem for 4-noded bar element if we have to find out the coordinate x and y at any point at a master location of P, right, and nodal displacement. Thank you.